Hello, everyone. In our final lecture here, we're going to be taking a look at invoices, invoice.java, and useinvoice.java to take a look at this concept of nested classes. So far, we have seen nested for loops. We've seen nested loops inside of each other. We've seen these concepts of nesting before. We can also go ahead and nest classes inside of another class. The reason that you would want to do this is to avoid making making a package very cluttered up with objects that are only used once. For instance, a good example is how we made another entire class just for a single comparison method. Nesting classes can be a better alternative to that and would avoid making too work for us. So there's going to be two ways we can write nested classes: a static class as an inner non-static class, and we're going to look at both of them. So we're going to take a look at static nested classes first, and whenever we make a static nested class, it's going to be used by the enclosing class only. What that means is that the class that it's nested inside of is the only one that could use it. Now, to actually take a look at this, there's going to be a few different ways we could approach this. Inside of the invoice.java file, you'll see here that I have public class invoice. I have this I have this attribute of my class called items, which is an array list of item. And item is actually a class that's created inside of my invoice class too. And you'll see down here, this is actually the invoice constructor of the invoice class, but right here is a full definition. You can see here, public static class item, and each item is having a description, quantity, and a unit price. We have two different constructors for each of our items, and you can see here that we have public double price, which does that for us. Now we'll have a print bill method right here that looks at system.out.println, shows us the invoice. It prints out every item a part of our invoice class. And we also have this neat method called public void add item that's a part of the invoice class. So let's actually kind of explore what's going on here. We can make either this nested class public if we want to. In this case, we want to use the standard encapsulation techniques with making variables private. Otherwise, we can actually make this private ourselves. So why don't we actually try to look at both ways that we could do this. In the use invoice Java file, if you run it, you'll see that we create a bill called the bill as a variable, and it's going to be a new invoice object. We have two items here that we're adding, and the bill is, because this is the invoice class, the bill is a method. Add item is a method, a part of the bill. So we're going to add in an item, and the item we're adding here, it's going to be each of these. And then we can see that we can print the bill. And we'll see right here that we have this method, which is a bit more complicated looking. It says invoice.item. And what's going on here? Well, item is actually a part of the invoice class. And because it is, we could actually go ahead and create another item here using this. If we actually print out the lots price, which is the tuna that we just added, it's going to be working just fine. So this right here is a little confusing about what's happening, and let's actually experiment a bit with this. So what I'm going to do is I'm going to delete these comments here, and you'll see that this item object is now not working like we wanted it to. So I'm going to comment out this one here, and I'll actually try to comment out a few of these guys. And it looks like the price is also there. So let's do it this way. Sorry. Oh. Now what actually changes here when I run this code? So we'll see now that I get this new error when I made this private static class of item privatized. We'll see that I get this issue. The type invoice.item is not visible. So again, we can see here that if I kept it at public, I'm able to actually immediately manipulate the nested class that is a part of the enclosing class. And again, item is nested inside of invoice here. Otherwise, if I don't want the user to do that, then what I can do is this concept of using the methods that are associated with the invoice class, such as add item, to take care of the creation of items for me. So again, in general, let me just type this out for us really quick. If our nested class of item is public inside of our invoice class, then we are going to be able to access it by using invoice.item. But you'll notice here that if I don't have the it as public, it won't be there. So let's go ahead and change it back really quick one more time. So I'm going to comment these guys in. And I'm going to uncomment these guys here. And we'll see now that if I say something like the bill dots, you'll notice here that I actually type in item, and it's going to be adding in an item. If I actually type in invoice.item, I'm able to have access to the class that is public here. And so because I have access to this class, which is public, I can actually go ahead and say item dots. And then let's try to make a few more objects here. I could do item dots and create a new item off of this, right? So I could say new invoice.item, and it's going to be taking in values. I'll just say test of 10 and 50. So again, this is usually the case when we say when we're trying to access new items here, and we'll see here. Looks like I left one more thing out of here. Oops, I left my variable name. Apologies for that. There we go. Now, again, the only difference here that I did is that I made the public class into privates, and that shifted around what I could do here. So again, nested classes are useful for our purposes, and the main difference I want everyone to remember is that you can do stuff like this where you have a class with a class nested inside of it, and essentially you just need to add on a little bit more to the left side of this class to make these work, right? And again, nested classes is useful. And what we could look at is the alternative here, which is called inner classes. So when we're using inner classes, we're not going to make the nested class static because that has implications for how we can actually use that class, because static classes are a bit more strict with what we can do with them. So what we could do is try to consider the social network, where the network class, network.java, has an inner class representing members of the social network. Now, each member of this network has a list of friends who are connected. And what we could do here is we could take a look at the modifiers that are present. So if we have the static modifier drop, the inner class can access instance variables of the outer class just by using their name. And that's going to be really important because you might be able to do things a bit differently in this case. So if we're going to take a look at this remove method here, so let's go ahead and take a look at network.java and use network. We'll see here that I have public class network, and then I have another public class called member. So this is a nested class of network that's called member. But you'll notice here that if I type in the word static, I might get a few errors that are present here. And the reason being is that if I look at these, cannot make a static reference to non-static field variable. So again, if I change this to static, everything else would have to change as well. So because this isn't static, I have access to items out of here, whereas with my invoice.java file, because this is static, I don't really have access to the invoice out here, printable, or add item. We have this method inside of network.java that is called created in, and we are checking network.dis is equal to n, and network.dis references this network up here. So we are actually going to be able to know, if we don't have this set to static, what object that we are creating. So again, if I change this to static, you'll notice here that my network.this, no enclosing instance of the type network, is accessible in scope. And so again, in general, what we're trying to do here is that if we make this static, we can't go up here. Otherwise, if we make it non-static, we'll have access to this scope. So again, this is where we can use a bit of enclosed classes for the time being. They're a bit more convoluted and complex, but they are useful based on some edge cases that you might encounter as well.